In today's tutorial we will have a look at the synthesis of Diclofenac, a very important drug. It's anti-inflammatory and it's also used for the treatment of pain. Here we have an original synthesis from the late 60s. In the first step of this synthesis, an arylation of that aniline functionality has to be achieved. This is done with an Ullmann reaction. So an Ullmann reaction is copper catalyzed here under basic conditions. Well, this is then the result of the first step in this multi-step process. Unfortunately, it's only achieved with 10 to 20% yield. Next step is a decarboxylation. It is simply achieved by heating this compound up to the melting point. At this temperature, it decarboxylates readily. How can we explain that? Well, at elevated temperatures, a protonation can occur at this position. Of course, it is under dearomatization. We get to this reactive intermediate with an iminium cation here and a carboxylate there, and this can simply lose CO2. The aromatic system is restored again. We are here at this product. The aryl abbreviation stands for this dichlorophenyl group. So in the next step, this is treated with oxalyl chloride, and an acylation will take place, and with the aluminum chloride a cyclization will occur. Clearly this is then a Friedel-Crafts acylation. So we have to get rid of that oxygen of this carbonyl group. We need a selective reduction, and this is achieved under Wolff-Kishner conditions. Hydrazine will selectively react with that ketone rather than with that amide. So selectively the reduction will take place here. Then we have here that CH2 group, and for the last step we just have to treat this compound with sodium hydroxide at elevated temperatures. Then an amide hydrolysis will take place and will directly produce the target molecule, the diclofenac. Well, because the first step of this synthesis has such a low yield and this drug is so important, of course, in the last 50 years or so, this synthesis has been much improved, and in the next videos we will have a look at improvements of this synthesis. Thanks for listening.